Hello, everybody. Welcome back. Today we're going to be doing something just a little bit different. I am taking some of the subunits for Unit 5 and I'm doing them a little bit out of order because that's just what makes sense to me. So what I'm going to be covering today is Unit 5.4 and 5.7 together. So that brings the topics of reaction mechanisms and elementary steps together, because to me it makes sense to present them at the same time rather than separately. So let's get started. All right, so the first thing that it's really important to understand is that when we look at a chemical reaction, we are simply seeing kind of the overall process of how did the reactants turn into products. Okay, we're just seeing a summary. What were the original reactants? What were the final products? But it doesn't tell us how a chemical reaction takes place. And it's important for you all to know that most chemical reactions do not take place in just one step. There's usually multiple steps, multiple mini reactions that eventually will get us to our final destination. And those sort of mini steps are called elementary steps or elementary reactions. Okay, they're smaller reactions that when we put a series of elementary steps together, it's going to give us a fuller picture of how a total reaction plays out. And that list of the elementary steps is called a reaction mechanism. So let's look at what a reaction mechanism might look like. Okay, so at the bottom of your screen, you have two reactions written there, okay, next to those little box bullet points. Each one of those reactions is what's called an elementary step or an elementary reaction. What's up at the top is what we call the overall reaction. Okay, and this is just a little vocabulary here. These two pieces put together, those two elementary steps put together, that is what's called a reaction mechanism. Okay, now what might you do with a reaction mechanism? Well, what we're going to do is we're going to be adding these equations together to get to our overall equation, which is what you see at the top of the slide. Now, we've talked a little bit about this before, but I want to refresh your memory. Okay, when I add these two equations together, I'm going to be able to cancel things out that are identical on either side of the arrow. So if you look at this reaction mechanism, let's look at what are some things that I can cancel out, some things that are identical on opposite sides of the arrow. For example, I've got NO3 gas on opposite sides, so I can cancel that out. I see something else, I can get rid of one of those NO2s, all right? And if you look at everything that I did not cancel out, everything that remains, that leaves me with what we call the overall balanced reaction there up at the top. Okay, so a reaction mechanism, guys, and here's a way to sort of think about it. If you are driving to a destination you've never been before, so what do? You pull out your phone, you pull up whatever GPS app is your favorite, and you put in that destination, okay? All of the steps, all of the different individual turns in the directions on how to get to that wherever you're going, those are sort of like the elementary steps. When you put it all together, the reaction up at the top, that overall reaction, is really just showing where did we begin and where did we end up. It doesn't tell us any information about the individual steps that got us there. Okay. Now, the good news is, guys, you will not be expected to come up with a reaction mechanism. Okay. If I just give you an overall reaction, you are not expected to say, oh yeah, I bet that overall reaction takes place in 3 steps, and then write them out. You will not be expected to do that. Okay, that's above the level of this class. If you're given a reaction, how are you going to know that it's an elementary step and not an overall? They will tell you. They'll either say the following elementary step, or they'll show you multiple elementary steps and say the following reaction mechanism. And if you see that term, that means that everything below it, those are all elementary steps. Now, these things that I've canceled out here, they have names, and I don't mean just chemical names, but I can use some vocabulary words to describe these things. Okay, so first of all, let's look at NO3. All right, we canceled it out because it was a product on one side and a reactant in the next step, so I could cancel them out. That, ladies and gentlemen, is what's called an intermediate. Did I spell that right? Yeah, I think so. Okay, an intermediate is something that is a product first, okay, which it was right there. It was a product in one elementary step, and then later on, it was a reactant. So an intermediate is something that gets canceled out, that is a product first and a reactant later. Okay, now what about NO2? NO2 does not fit that description, so it is something else. Believe it or not, ladies and gentlemen, NO2 is a catalyst. Okay, now let's think about what a catalyst does. If you remember back from Chem 1, a catalyst helps to speed up a reaction. So wouldn't it make sense to have that thing that you're going to need to speed up this reaction, to have it present right at the very beginning on the reactant side? You would want that present right away. So how do you recognize a catalyst? Like an intermediate, catalysts are canceled out in a reaction mechanism, but a catalyst is found as a reactant first and then pops out later as a product in a later elementary step. Okay, so both of these terms are things that are canceled out, but where they're found first and then second is what makes the difference. All right, so let's just review those terms. Okay, so an intermediate is something that is not found in the overall reaction, but it's formed as a product first and then consumed as a reactant later. A catalyst is also canceled out, not found in the overall reaction, but it is found as a reactant first and a product later. Okay. Elementary steps, okay, are those step by step directions from your GPS, okay? They're the little mini reactions, and we're going to talk about what this word molecularity means, okay? But I think it's a little easier to understand that term with some examples in front of us. Okay, so I want you to look at this chart. First of all, guys, molecularity is a term that you will only use with elementary steps. Okay, we don't ever use the term molecularity with overall reactions. Okay, and let's just look at these first 2 columns where you have an elementary step and what it says is the molecularity. And there's 3 types: unimolecular, bimolecular, termolecular. If you think about what the prefix uni means, that means one. Okay, if you look at the elementary step on the very first line, we have one reactant only and 1 mole of it, like meaning it has a coefficient of 1. That is what I would call a unimolecular elementary step. The prefix bi means 2. So look at the examples. All right, this what's on the second line here, this reaction, you might say, well, that only has 1 reactant as well, but molecularity refers to the number of moles that are reacting. Since there's 2 moles reacting, we call that a bimolecular elementary step. This one is also a bimolecular elementary step. The prefix ter means 3 or more. So if you look at these other examples here, you have 3 or more moles of reactants colliding and reacting. Okay, so again, that term molecularity is a term you only use with elementary steps. Now let's talk about what's going on in the column on the right where it says rate law. If you've watched the previous videos on the previous lessons in Unit 5, we've talked about different ways to find a rate law for something. One method we used is called the initial rates method. We were looking at these charts and comparing line by line. Another lesson we looked at some graphs and how you could find the rate law that way. Well, something that is unique to elementary steps, and that's why I've put these terms kind of highlighted in green at the bottom. What I'm going to show you now is a technique that you can only use with elementary steps. Okay, you cannot do this with an overall reaction. If you will look, let's just look at this one as an example. For an elementary step only, ladies and gentlemen, you can use the coefficient and turn it into the exponent. Okay, you cannot do that with overall reactions. Overall reactions, you either need a table of data or you need a graph. But if you're asked to write the rate law for an elementary step, okay, like look at this example right here, you can simply use the coefficients that go with that reactant and turn them into the exponents. Let me say that one more time because it's really important. You can only determine rate laws in this manner, using the coefficients and turning them into exponents, with elementary steps only. Okay, so let's look at a sample problem here. All right, I want you to read through it, pause the video, and see how you do. All right, so we were given a reaction mechanism that has 2 elementary steps, and part A says write the rate law for elementary step 1. Remember, since it's an elementary step, I can just use the coefficients. Okay, so my rate law is going to look just like that. Both reactants had a coefficient of 1, so they each get an exponent of 1. Letter B says identify the intermediate and justify your choice. Remember, intermediate means something that's going to be canceled out in the mechanism, that is a product first and a reactant later. NOCl2 fits that description. If I had asked you to find a catalyst in this mechanism, you'd have to say that there is no catalyst, and sometimes there won't be. There is nothing that cancels out that is a reactant first and a product later. So there's no catalyst in this mechanism. Part C, what is the overall chemical equation for the reaction? Cancel out that intermediate and then add whatever is left to those 2 elementary steps, and this is what I am left with. So that's, a type of AP question that you could see. Okay. So that's it. Now, as I said, I've combined units 5.4 and 5.7, okay, together into this one video. And the remainder of unit 5, if you're following with my videos, I'm going to go a little bit out of order because that's just what makes more sense to me. So anyway, I hope you've learned a little something, and I look forward to seeing you next time.